Alrighty, so this comes from section 1.5. I've basically taken 3 textbook sections and pushed them all together a little bit. Tried to pull out a little bit of stuff to make it go by a little faster, but we got to cover a few things. I did some checking. A lot of this stuff is actually stuff that you probably should know from grade 7. Of course, everyone remembers their stuff from grade 7, right? So we'll try to cover it real quick. Thank you. So we'll start with the first question here. See what you guys know about this already. Hang on, I got to click start assessment.
Bob's your uncle? Yeah.
Bob's your uncle. So today, I've already put that up there, but here's what you're going to, I covered it up already. Biotic antibiotic factors, we're going to cover community and population, ecotones, ecosystems, you're going to understand food webs, and energy transfer is important.
Ooh.
Carly doesn't have her FM today, Mr. Reeves, so she's going to have a tough time, yeah.
Scroll down a little bit. I get it as well.
Okay, have we got an answer? I'm waiting on a few people. We're going to have to be a little quicker, you guys, if we're going to get through stuff. So I'm waiting on Rowan and Stephanie and Hannah and Maria.
I think yours was 11 on mine. I'm not sure.
Carly? One, no. Where is she? 1018. We're going to go on without you guys? Okay, good idea. Reese's. 1012. 1012. Okay. Herbie, are you in? You are now. Correct answer is C. An organism that causes a problem for humans are called, not Bob, not a nuisance, but they are called pests. And I've got a couple examples here. They would be what? Mosquitoes. I think that's a wasp or a hornet, right? Can you go see what Stephanie needs there?
Yeah.
Okay. But the deal is, it would sure be nice to get rid of mosquitoes, though, right? Wouldn't it be nice? But mosquitoes have a role in the ecosystem. What would mosquitoes' role be, do you think? Bingo. Can you write that in on yours? They are a food source. Mosquitoes are a food source. Who has crabgrass on their lawn? Just Mr. Reeve and I, apparently. Crabgrass, that ugly-looking grass, right? It's also a food source, but it also prevents erosion by holding the soil together. Because it is a weed.
Oh, yeah.
Right? You know that grass that grows really fast? Yeah, just about everybody at Dawson's got it. Mark, are you copying these down, or are you basically just watching the clock to leave at 1:20?
How does that even look like?
I know.
I'm mostly watching the clock and doing that.
Oh, okay.
But mostly
Pardon
watching
me?
the
Those are two separate things. Crabgrass is a food source for things like cows and stuff like that, and it also prevents erosion by holding soil together. So it has its benefits, although neither Mr. Reeve nor I, I'm sure, have cows on our lawn, nor are we worried about erosion on our lawn. No, I'm not. Where do you think the word ecology comes from? Like, it's an English word, but all words come from places. So, do you think, and this is in the book, by the way, you could be looking it up as you go. Is it the Greek for oikos, the place where one lives, and logos, the study of? Is it Latin for eco, life, and logi, science? Or is it Egyptian, ek, the god of life, and ology, the god of learning? And I will say one thing, I made 2 of those up. It was coined by this guy here, Ernst Haeckel, a German biologist in 1866. Oh, I need to start it, don't I? I heard someone... Okay. Do you know the word abiotic? That's one of the words you need to know by the end of today. Abiotic factors. Do you know what that means? You're a good man, Briar. Abiotic means living items like birds and mammals, a single non-living factor like the wind, non-living factors like wind or climate. I threw a little trick at you there. Abiotic factors in an ecosystem are living items, not a single non-living factor or non-living factors like wind or climate. I feel like I'm on a game show. I'm the host of a game show when I stand up here and do this. Except there's no fabulous party prizes, nor is there any cars or
How about money?
dinnerware. No money, no. It's just fame and glory. Just glory. Hello, Mr. Smigalski. Did you get those down? What about biotic factors? This one you should get now. So, I got started, right, Brian?
Yeah.
Thank you. Thanks for reminding me. Biotic factors are biological superpowered wood ticks.
True.
It's not true or false, Josh. Biotic factors are humans, or biotic factors are all living factors in an ecosystem. And I think Mrs. Jensen has a Christmas present for me. Survey says, did anybody pick biological superpowered wood ticks?
Yes.
Yeah, someone did. You did, didn't you, Josh?
I did.
All living factors in an ecosystem. Those are called the biotics. It was C, right? Right. Okay. Awesome. Now, the word population, when I say population, what do you think of right away? Like if I talk about the population of Dauphin, what does that sort of mean to you?
People.
Number of people, exactly. So, in a little different sense, in the ecological sense, which of these do you think is the best description for the word population in the ecological sense? Is it the number of people in a city or town, the number of animals in an ecosystem, or the number of animals that could be of the same species? No, quite all right. Don't worry about it. Number of people in a city or town, number of animals in an ecosystem, or number of animals of the same species. So like the number of northern pikes, or the number of ants, or the number of deer, or that type of thing. Well done. You guys remember all this stuff. Well done. Number of animals of the same species. Okay? So the number of deer, number of bees, or what have you, the same species. How'd you do? 4 minutes. Okay, awesome. Which of these best describes the meaning of community in the ecological sense? What is the word, when you talk about community of Dauphin, I don't mean the hotel. Kind of got a couple of smiles there. The community of Dauphin is kind of everything in Dauphin, right? There's one just down here. Well, was there one there? Okay, go ahead. I didn't know that was there. Which of these? Yes, Brian. Good luck, gentlemen. Go defend. Okay, how do we do? Correct answer? C. Oh, I kind of tricked you a little bit there, didn't I? Right? So it's all of the different species that live in an area is the community. So we're talking all of the eagles, all of the birds, all of the fish, all the ducks, everything, right? It's not the number of a single species. Switching bars on here. All right. Ecosystems have boundaries that may not be well defined. Like when you go down to Vermilion Park, and there's the Dead River, right? There's the ecosystem of the Dead River itself. And then there's the park itself, right? And there's a pretty distinct boundary. It's where the water is, right? But not all ecosystems have that type of very distinct boundary. So there's transition zones, and they call these, and it's in your book there if you follow along. Do you think they call them I need to press start, don't I? Hold on, I did it. Do you think they call them transition zones, ecotrans, ecozones, or ecotones? Ecophones? It's not up there, Josh. Ecophones, yes. It's a phone made out of wood. No. Well, they've learned not to laugh at my jokes. Taylor? Other one. Yeah, the correct answer is D. You guys must be following along, because you didn't know that before today, did you? Did some of you know that before today? Ecotone? Oh yeah, right. Good thing we did that. I forgot about that. Now, what do you think about ecotones? Do they have less biodiversity than the neighboring ecosystems? Do they have more biodiversity than the neighboring systems? Do they have the same amount of biodiversity than the neighboring systems? Or do you think it varies from ecotone to ecotone? And you're probably wondering, what is biodiversity mean? Anybody want to take a run at what biodiversity means? What does the word diversity mean? Many different kinds, a variety. So biodiversity would be? What do you think, Brody? Many what? Many, no, it's more about the many animals, many species. Okay? How many different species are there? So an ecotone is between those two ecosystems, right? It's that area in between. There was a picture here on the last slide, right? So the ecotone is this sort of in between here. So do you think that that in between has lots of different animals, not so many different animals, or the same amount is in each?
Because
Oh. I'm being distracted.
I'm so sorry.
That's okay, easy. Is there a light right there? No, I know, but we'll make sure you
Yeah, on the thing it'll show
because
us.
this one here, for some reason, the one side works, but the other doesn't.
Okay.
I'm waiting on Rowan and Taylor. Less biodiversity, more biodiversity? Same amount? Rowan, thank you. Correct answer? Yeah, you guys are doing good. More biodiversity. More. How come more, you think, Josh? Because I could tell that you got it right. Do you know why?
because it says it in the textbook.
No, that's not the reason. It's because the deer come from ecosystem A and sort of wander close to ecosystem B. Exactly. They're like the animals don't follow, like they don't need a passport to go from ecosystem A to ecosystem B. They wander in and out, right? They move back and forth. There's organisms from both ecosystems are in the ecotone, right? You guys have seen these kind of diagrams in math class before? What kind of diagrams are those, do you know? Yeah, exactly. Good, well done. Venn diagrams, right? So there's ecosystem A and ecosystem B, and this here is called the ecotone. And so the little deer, the little animals, right? They wander around, they're in the ecotone. There's other ones over here. They're the same kind of looking thing, they're just red, that's all. Right? They go into the ecotone. So this area here has red animals and blue ones. Does that make sense? And we call that more biodiversity. And regions with greater biodiversity tend to be stronger. They tend to last longer. Oh, this is so exciting.
Actually, boys.
We'll just wear it like that.
Yeah, that's gonna hold.
Go to their concerts and look out 30-year-old woman there.
Dion is awake.
There you go. Play like that.
Testing, testing. 1, 2, 3.
Don't get us started. Don't clap or anything.
Luke, I have no problem.
Okay, volume wise?
I don't know. Will you tell me?
Oh, well. Oh, I can hear
A little
you
more?
right here.
Is that respecter? What did you tell me?
Can you hear, Brody? I'll have to. Just sounds like I'm talking.
Okay, well, if you turn it off, okay, keep talking.
Okay.
Okay, just say something.
Luke, I am your father.
How about read that ecosystem?
Okay. Ecosystems with greater biodiversity tend to be stronger.
Go.
Ecotones, with their high levels of biodiversity, guard against extinction.
That's much different.
Really? I can't even hear that.
Can you guys hear the difference?
I can.
Yeah.
I still want to talk in my usual indoor.
It's a big difference, yeah.
Is that right? Eh?
You can't? Yeah, well,
I
I was
used to
gonna,
be able
I was
to
going
read.
to insult you, but.
I used to hear Mr. There's not really.
I can't. Just
Okay.
put
You want louder? Hey, try it again, maybe for a second.
Ecosystems with greater biodiversity tend to be stronger.
Okay. hold on.
Ecotones with their, oh,
Okay, try again.
ecotones with their high levels of biodiversity guard against extinction.
There it is.
Better? Okay.
That sounds like it.
Volume, first knob, first one to the left.
To the left?
Okay.
Okay. Is it not labeled volume?
There's like channel A, channel B, microphones,
Oh.
audio in, audio out.
Okay.
That's
I'll
fine.
figure it
The little instructions are at the back.
Okay, thank you very much.
Have fun, let me know. how it
So
works.
does that tie in with Carly's system or?
Oh, well,
Not likely.
yeah,
It will or?
yeah, but we're working on something.
Okay. Can you hear me, Carly? Yeah? Okay.
Okay. How about me?
Can you hear me?
Can you hear me now? Yeah, can you hear me now? If I start talking too loud because I like to, until I get used to this, just wait and say you're way too loud.
Would you like to hang on to this so that you
Exactly.
can put videos or wherever, this could be your speaker system for the.
Well, maybe
What?
I've got sound.
Yeah.
That's actually pretty good. I can stand right here and it doesn't. Okay, thank you. No, that's quite all right. We'll manage it. Okay, so the idea is with these ecosystems, or sorry, with these ecotones, is because they have a lot of biodiversity, they tend to be very stable. They do not lose species. Okay? They do not lose species. Awesome. We need to talk about energy in ecosystems. And again, I think a lot of this is kind of repeat from grade 7, so I'm just refreshing your memory here a little bit. I think you guys switched to booklet 2, right? Because I planned them to be 2 separate days, right? Am I right? Booklet 2? Oh, we were recording that entire time. Oh well. All energy in all ecosystems begins with all energy in, this is, oh, you have to flip ahead, don't you? Section 110, what page is that? Anybody found it yet?
32.
32. Awesome, okay. What do you already know, do you think, about the energy in ecosystems? Where does it start? Like, there's got to be a beginning spot for the energy.
Got it.
What do you think? Got it, Josh?
Yep.
Got the answer?
Yep.
You should know this.
I should.
Do you think you're right?
No.
Does it begin with the producers, the consumers, the sun, or wind energy? Is it? Okay, well, find out.
I also have like the text on both.
Oh, yeah. I would say you're cheating, but that's exactly what I want you to do, so we'll go with that. Correct answer? Yay, you got it right. The sun. Oh, is it also on your page, a big picture of the sun?
Yes.
No.
Is it on your page?
Just
Yes. And then also the first like sentence is like the source of all energy for equals.
Oh. You're smart. You're smarter than the average bear, Josh. There's only one person in the room that gets the reference. The sun lights and warms the earth. It evaporates the water. It provides energy to plants. Man, that sun is powerful. How do we get energy then from coal or gas? Like when we burn coal or we burn gas in the engines of our vehicle, how do we get energy from it? And I got the answer up there already. I forgot to hide it. What is the answer? Is it on the sheet too? Good thing Briar's not here. Burn it. We burn it to produce steam that produces energy. But this one is not on the sheet. I know that. What is the process called that plants use to take solar energy and create food? Now, I think this was on that review thing we did at the start. Yeah, I think it was, wasn't it? So everybody should get this.
Overhead.
You should feel the pressure, because you should get it. What is the process called that plants use to take solar energy and create food? This Mr. Reed to look at.
Oh, thank you.
Okay. Just have a look at that, and then we'll go through that hopefully before you leave. Reese, come on, man. Too late. B, photosynthesis. Photosynthesis is taking the sun's energy and converting it to Glucose, sugar. Now, this one, you're going to have to pull out the book. I don't expect anyone to know this off the top of their head. That'd be craziness. Of all the energy that is released by the sun, how much do you think actually reaches the Earth? Of all the energy that leaves the sun, how much gets to the Earth? Is it 100%? Is it about half or 50%? Is it about a quarter or 25%? Or is it around 1 billion? 1 over a big number. Billion has 9 zeros in it. What do you think? You're pretty sure it's what?
E.
E. You probably will be surprised by the answer. Find it, Taylor? Brooklyn? Still look. Oh, she's answering now. Correct answer? Yeah, it's D. 1 billionth. Like a teeny, tiny, itsy bitsy bit of sun's energy reaches the Earth. There is a ton of energy that goes where?
Everywhere else.
Out into space that is completely and utterly wasted unless there's alien life out there, and they're figuring out how to use solar energy. Let's hope they are. So, now here's just, I'm just going to go through this really, really quick. Most of that energy goes off into space, but about 1.74 times 10 to the 17 watts strikes the Earth. That's 174 quadrillion watts of energy. When you put up a 100-watt light bulb in your house, think about how bright that is. That's 100 watts. And how much bigger that is. Think about how bright the light bulb would be if it was 174 quadrillion watts light bulb. That's how much energy reaches the Earth. If there's no clouds in the way, 1 square meter of the Earth will receive about 1 kilowatt of that energy. So for 6 hours in the middle of a sunny day, an area the size of a small backyard swimming pool will receive about 288 kilowatts of energy. That's nearly 10 times what the average U.S. household uses an entire day. In other words, if you have a little bit of backyard space, about the size of a backyard swimming pool, if you had that in solar panels, and if you converted all the electricity, it would power 10 houses. Why the heck are we not doing this? That's for another day. Well, why don't we use more solar energy and less coal and gas energy? Maybe it's not for another day. What do you think? Why? Why don't we use solar energy? It costs a lot to do what? No, you're right. The solar panels are expensive, right? That is true. And we've built up huge infrastructure. On every corner there's a gas station, right? We all have natural gas pumped to our homes. In the United States, giant power plants that run on coal. We've invested millions and, well, billions and trillions of dollars. And we haven't pumped it into solar energy. That was sort of the easy way, and now we're faced with the dilemma. And not only that, but the companies that run those, do they want to lose their profit? No. So that's another problem. What is the albedo effect? Albedo refers to, it is not Obama. Albedo refers to a person with no skin color or pigmentation. Is it an African water mammal? I did make some of these up, by the way. I'm not giving away any hints. Is it a measure of the amount of light that is reflected, or is it a measure of the amount of light that is absorbed? Back table should have got it, might have?
No,
Yeah? Why is that?
they were talking about it in the
Oh, is that right? Really?
beginning definition.
Just how, oh, when they're doing the definitions. Albedo refers to the amount of sunlight that is reflected. Exactly. So, do you know, ladies, that we're defining the other day, is it the higher the albedo number, the more light reflected, the less light reflected, or the same amount of light is reflected? The more light, the less light, or the same amount. The higher the albedo number. Then I'm going to ask you for some examples right away.
What was the answer? What was the answer for last
What was
one?
the answer for 12? It was the amount of light that is reflected, C. Shame. So, higher albedo number, the more or less or same amount? Wait, Rowan. Correct answer? Higher number? What's the answer? Oh, where's it? Where is it? So tough. Yeah, A. Higher the albedo, the more light reflected. So, which of these do you think would have the highest albedo? Would it be fresh snow? Would it be asphalt, shingles, or grass? Which one would reflect the most light? Fresh snow, asphalt, shingles, or grass? You've probably been outside in the summertime. You've probably gone skiing in the summertime. Outside in the wintertime, right? It can be incredibly bright out there. On a bright sunny day when we've got fresh snow on the ground. Oh, I think I kind of gave it a wonder. This doesn't really work when I put my hand over it. It makes it holler, doesn't it? Mm-hmm. I can't whisper. That's pretty cool. Okay?
Okay.
If I do this, does that work? Oh, that works. Kool-Aid grease. Yeah, correct answer is a fresh snow. Which one would have the lowest albedo? What do you think? Quick. Oh, we're going to start. If something has low albedo, like if you put your hand on fresh snow, do you feel the heat being reflected? But you certainly see it, right? You see the light. If something doesn't reflect light, then it absorbs the light, it absorbs the energy, and it gets what? It gets hot, it gets warm. So which one of those would absorb the most heat? Would it be fresh snow, concrete, shingles, or grass? Okay. Last one, I promise. You guys have been doing really well here. Oh, we're going to finish in no time. Energy movement in ecosystems. Do you know what the word trophic level means? I think the questions end now because I think I was racing through last night trying to put stuff together. I'm going to finish in no time, and I'm going to be short. I'm going to take long enough. Trophic level describes where in the food chain that an organism is. Did you learn that in grade 7? You think trophic level? No? Okay, so the trophic level refers to where in the food chain an organism is. Now, this should be right on your sheet, right? So the first trophic level, second trophic level, third trophic level, fourth trophic level. Which way does the energy flow? What do you think? I've heard it a couple times, I think. Is that right? Does energy flow this way? And the answer is yes, of course. Energy flows up. Energy flows up. So the grass, where does the grass get the energy from? The sun. Where do the rats get their energy from? The plants, the grass. Where do the snakes get their energy from? The rats. Where does you look at the hawk? The hawk get his energy from? His or her energy from? From the snakes, right? The energy flows up, but it all comes from the sun. Notice that the shape of this is a pyramid. Why do you think that is? Tough question. This is the big question. This is the thinking part of the day. Well, you're right about that, Brody. There is like once you get up here, there's nothing, right? But you're right about that. But that doesn't explain why it's shaped like a pyramid. I'll give you a hint. How much grass is there down here? A lot, right? There's a lot of plants. How many rats are there? Sort of a lot. And in the picture, it certainly shows that there's 5 rats, and then those guys feed 2 snakes, and it all feeds 1 hawk. Why is it a pyramid?
Because there's more on the bottom than there's on the top.
More organisms at the bottom, less organisms at the top. Can we put this on here? More organisms here. Less organisms up here. Oh, that's remarkable how it knows my handwriting. More organisms at the bottom, you're absolutely right, Josh, less at the top. Now, I'm going to have to ask you this again. Why? Why is there less at the top? I'll give you one small hint. Think about the size of grass plants and the size of rats and the size of snakes and the size of hawks. Hawks are bigger. Who's the biggest guy? The top trophic level, the big dog on the street, right? He's big. So that he has to eat lots of snakes, who in turn eat lots of rats, and so on, okay? So because of the size of them, that's one reason. That's why we've got it in this pyramid shape. What happens to energy that the plants get from the sun? Where does it go? Well, it goes to the rats, but does it all go to the rats? And here is the key. It does not all go to the rats. Plants use up their energy. Okay? Plants use up their energy by growing. That's about all grass really does, is grow, right? It doesn't do a whole lot. So the plants use their energy to grow. So only a small portion, only a small bit, a fraction, a little bit is stored for the rats to eat. Any idea what the next slide is going to be all about? I'll pause. What happens to the energy that the rats get from the plants? Right? All this energy here that the rats get from eating the grass or whatever they're eating, what happens to it? What do rats do? Rat stuff. They run around and make rat noises and chew holes in things and stuff like that. Rats have lives too, you know. Yeah, they use it for running around, staying warm, growing whiskers, basically living. How much energy is stored in the rats? Not a lot. Some of the energy that came from the grass that went to the rats is stored in the rats, but not a lot. Right? Would you say that there's now less energy here? Would you say there's less energy at the second trophic level? I think you would agree. And what happens to all energy and so on? I think you get the picture here. What happens to energy that the snakes get from the rats? Guess what? They use up... Oh, I don't have it. They use it up doing snake things, whatever snakes do. Oh, I thought it was shark things. It's because they use it to call it. Yeah. They use it up for shark things. So all together, and this, my friends, is the big idea for the day. There is less energy available at the top, so there are less top-level consumers. There's always less top-level consumers. What are some other top-level consumers that you might know of? Like, what would be the top consumer, top carnivore in Riding Mountain National Park, do you think? Well, there's certainly humans that live up there. Pardon me? Probably wolves, I would think, right? Wolves are yeah, I would probably say the wolves, right? How many wolves are up there? Hardly any, right? And same thing with maybe mountain lions. There's only, like, you don't see them, but they say there's a couple, right? Hardly any. But there's a lot of grass, right? There's a lot of beavers, there's a lot of mice, there's a lot of rabbits, not many deer, maybe a few moose. As you go up, The animals get bigger and there's less of them. That's the key thing to know from today. Okay, almost done, and I'm going to be done way too early here. I didn't have to go pedal to the metal. Food webs. This is an example of a food chain. It is they are single organisms in a line. Even though it's shaped like a pyramid, it's still a food chain, right? That make sense? Food chain? So what are food webs? What would you say, how would you describe a food web? Reese?
That's what animal you get feeding that animal, and that animal eats like it keeps going out.
Okay. Is that any different than food chain? Not a lot. I mean, I know what you're saying, and I think you've got a picture in your mind, right? If I show you this picture, let me just do this here. Oh no, I need to go like that. If I show you that picture, is that what you have in mind, Reese? Are those food webs? Like, how is that different? How are those two things different than this? This is sort of like one arrow, right? Rats eat grass, snakes eat rats, hawks eat snakes.
It shows everything in relation.
Yeah, it shows everything. Would you say that it's a multiple or many food chains sort of put together? Interlocked, like a puzzle kind of thing, right? So if you had to write a definition of a food web, it might even be right on your sheet there, is it? No, I guess I didn't even. Okay, well, we should probably write the definition of a food web. Let's do that. How would we describe as a group a food web? Anyone? Jalen? Savannah? How would you start? What would be a food web? Is it many food chains? How would you say that, John? Say that again, John?
Food chains that interlock with each other.
Okay. How about, can we say a collection? Can we start with that? And then we'll add in Josh's stuff. A collection of food chains that interlock. Does that sound good, Josh? Reese, you good with that? Collection of food chains made it a small tiny. Collection of food chains interlock. Generally, the larger the organism, the less the number there are in the area. As an example, lots of grass plants, much less deer or mountain lions. I'll leave that up there for you for a second.